Hello, everybody. I'd like to introduce you to Braden Cagle, who will be presenting today on simple coding projects for students in Division 2 and 3. Don't know about you, but I'm really excited to learn from Braden today because Division 2 is where everybody's focus is going to be next year, and then heading towards Division 3. So to have a sense of what this could possibly look like in Division 3 through those coding projects will be, I think, really valuable for all of us. So Braden is a teacher at Victoria School with Edmonton Public Schools. He's a science guy, which he has mentioned himself means that when you're working at an art school, the science guy is not always top on the priority list, which I think opens the door for him for all sorts of innovation under the radar. So looking forward to hearing what you come up with today, Braden.
Yeah, thanks. That's pretty accurate. Do you mind just giving me hosting power so I can present?
Oh, right. Sorry about that.
But yeah, I've been at Vic for 10 years now. It's a great school, arts kids. Yeah, science isn't usually top of their priority either, but you try to do what you can to make it interesting for them. Just finished a Master's of Educational Technology at the U of A. Yeah, and I'm excited to present to you today. Okay, let's.
You able to share? Oh, good.
Yep. Okay. Yeah, so these are simple coding projects. I'm just going to go through like what computational thinking is for anyone that hasn't been to my previous sessions. And then I'm going to cover 4 grades just so we're not totally overwhelmed. So grade 5 and grade 6, and then grade 8 and grade 9 in the Div 3 there. So we'll have, by the end of today, I'm sure you can adopt a lot of these for whatever you're doing. These are just focusing in, I just wanted to focus in on 4 things, and I think that'll take us all the way to an hour. So, yeah, so my interest is in education and media ecology. So like how technology affects the ecosystem inside the classroom and broader. So the goal for this presentation is to give you like roughly 2-week projects that are free, and they'll give you some good starting points to kind of take what you want, leave what you don't, and at the end of this, hopefully you can create a project with fairly minimal effort on your end so you can get started pretty quickly. So what is computational thinking? It's just a specific way about a specific way to think about and solve problems. It's not anything unusual. If you're more math-minded, it's just a way you do it all the time anyway. It's just a specific way that we talk about learning and thinking. So the new K-6 curriculum has computational thinking explicitly. So even my wife, who teaches grade 1, she has to involve computational thinking in one of her units. They took out color and put in computational thinking. So it's explicitly there for Div 2. It's already in there. Div 3, it's not yet, but I'm anticipating it will be when the curriculum changes. But there are ways that we can kind of get started or continue what the K-6 are doing right now. Okay, so the main ideas for the grade 5 and 6 projects, these are things associated with computational thinking. So pattern recognition and debugging, that's especially prescient in grade 5. There's a whole thing about debugging that we'll talk about. And then there's abstraction, which is more focused on the grade 6 project. That's just distilling down the what's necessary and getting rid of anything that's not. We'll talk about that more when we get to it. And then collaboration is hugely important in computational thinking. Any type of computer science is hugely collaborative. Some might even say, if you were to take what computer scientists did and put it into a different field, they'd call it plagiarism. But in computer science, it's more just nobody knows where anything came from anyway, so you can just borrow and steal as much as you like, and as long as you're doing something unique and different with it, no one minds quite so much. For grades 8 and 9, the principles are a little, some are similar. Collaboration is a big part of it as well. But it's going to focus more on decomposition. So chunking, you might have heard about that before, breaking things into smaller parts. There's a lot of evaluating. So anytime you're doing computational thinking or coding, you have to make judgment calls. You know, there are no solutions, there are only trade-offs. So if you want your code to do exactly what you want it to do, that's great. But what are the trade-offs of that? Oh, it might take up more computer space that you don't have. It might do all these things that you aren't aware of until you build it, that it might create some bugs. So making those judgment calls is hugely important in computational thinking. And then creating something new with guidelines, I think is really crucial. So the theoretical background that we have that we're kind of basing everything off of is constructionism. So constructionism is getting students to create something, they learn while they build it, and then you also have an artifact that you can look at and see the growth, see the learning. The students can look back on and say, oh yeah, okay, I remember how to do that. I remember that I had to learn this in order to make this artifact. So at the end, rather than have, like, for example, I've had students do coding projects where there is a reflection. I've also had them do coding projects where there isn't a reflection, but they can look back anyway and see, oh, this is the learning here. So typically, this would be an example of constructionism, building a model of an atom. And then this is like what constructionism could look like in computing science, where you have lines of code as your artifact rather than an actual real life model. So a personal anecdote that applied to me in physics 20, I was a physics major in university, so I thought I knew my physics really, really well. And then for a university project, I had to design a game that used those physics. And it was incredibly difficult to make, in order for me to make these 3 lines of code, it took me like 2 hours, and I realized I didn't know as much as I thought I did. So I was operationalizing my learning, even though I thought I was very, very strong in physics. It's just a different kind of having to put it to use using coding language is a whole different thing. So it's, yeah, that's kind of the whole point. Okay, so this is the first project. So this is the grade 5 project. It's getting the students to make a program and then turning it into a bad program. Okay, so something that doesn't do what you want. Now, all projects I'm discussing here, I'm assuming that the students have some basic coding competency, because coding, at least the curriculum starts in grade, now it starts in kindergarten, but even still, there are some things that the students will have to know in order to do these things. So very, very basic coding, not anything past what their level should be, but that's what the assumption is for these projects. So the idea for grade 5, students create a program that include loops, which we'll talk about if anyone's not sure, because I want to make sure that this is very, very basic for everyone here. Inside of a group. So the program could be anything at all. They can make any program they want. A good starting point, if you want to narrow it down, would be a program that makes a shape. Okay, so you have a computer program that can make any shape or a specific shape. Okay, then the students make sure that their program works almost all the time. So when you press play, the program works, it makes the shape it's supposed to. Okay, so those are the first two steps. The next step is that that group adds or takes away a block of code to make the program not work anymore. Okay. Then you give that program to a different group, which has to read their code. So they have to figure out what their code was trying to do in the first place and then debug it. So either add a piece of code in or take a piece of code away. So they're having to pick out what it should do and fix it. This is a scalable project. So first round, you do one thing wrong, pass it to a different group. Second round, you get the people to add 2 bad lines of code or add one and take one away. So there's 2 mistakes. Give it back. Can they fix it? 3 mistakes. And you can just keep doing that as your project. And then you can also do like a game of telephone with it, where you have one group that created the original. And then you pass it along to a different group. They mess it up. Okay. Then they pass it to a different group and they mess it up. And then you can keep doing that and then give it back to a different group. And okay, now you have to fix it. Okay, so every time you're giving it to a different group. So it's not just, oh, I just have to go back to where it was. Now you're dealing with somebody else's code where even if it's making the same object, they could be doing it in different ways. So each time you have to pick out and choose what you're doing to fix the program. Okay, so I'll show you what that looks like. So this is the program that I built. I built it in, I don't know, roughly 5 minutes. Like, it doesn't take very long to build something like this. So you guys can probably guess what shape this is making by reading the code. You can type it into the chat what your guess is. I'm hoping we can all do this. At least I'll guess. Even if you don't have coding experience. Yeah, thanks. Yeah, it's a square. Yeah, good. It's a square. So it's just, so this is what I built. I'll just put it on here instead. Oh, what? Why would it not link? That's okay. I'll just sign in. Oh, okay. It's private. That's fine. Okay, so here's my little bit of code. You can see this little scratch cat that I have. And as soon as I press green, it will make a square. So you can see, it actually took me a bit. I didn't using this program, it's pretty easy to figure stuff out, but there is this little hidden bar here where you can get all these other extensions automatically on it. So if you have like Lego Mindstorms or video sensors, or if you want to do something with music, they have these whole separate bins that you have to get to, which that took me about as long to figure out as it did to make me write this whole thing. But once you know that there's a pen and you can erase it, then you can just make the program. So you can see how adding in or taking away or changing values here, like if I make this like, I don't know, like 3, right? It's gonna do something different, and it's not going to make a square anymore. And then that's it. So, okay, now you give it back to a different group. What can they do to make it better? Okay, they fix it. Now mess it up even more. So every time, every time you're having to analyze and fix it. So that's the first group. You can scale it up, scale it down, do it for a few days, do it for a couple weeks, do it, then come back to it later as a backup plan. There's lots of choices with this. And these are all the grade 5 outcomes you get by doing this project. So you get to make a computational artifact. They're creating an algorithm and putting it into code. They're doing something that includes multiple iterations of a program. They're enhancing and refining. It's done through collaboration. Oh, I mentioned about loops. This is a loop. for anyone that isn't aware. Repeat 4 times. So it takes these bits of code and repeats it 4 times. So it's looped 4 times. So that's all a loop is. So they're getting that. Yeah, multiple iterations, more loops, enhance collaboration, explain what will happen when single or multiple blocks of code are executed. So that's when they have to look at it and say, okay, what is this code going to do when I press play? What kind of shape is it going to make? Can I read the code and figure out what it's going to do? Okay, so those are all the outcomes. Those aren't all the grade 5 outcomes, but these are just the ones that this one little project can hit. Okay. Any questions about the grade 5 project? Okay, on to grade 6. Oh, yeah, sorry. Maurice, you can go ahead.
How do you share a scratch between students?
So you can just give them literally the computer.
Okay, yeah. Okay.
Yeah, you can just transfer the computer. I think that would honestly be the easiest way to do it rather than sharing and stuff.
Okay.
Sharing on Scratch can be a little tricky, but yeah, literally just having them move computers to a different group, I think that would probably be the best way to do it. Okay, on to grade 6. So grade 6, this one's a little bit more fun, a little bit more involved. The goal is to create an abstract game. Okay, so what an abstract game is, you think of a game and then you put it down to its nuts and bolts and you play that instead of the real game. So classic example, tennis you can turn into Pong. Okay, Pong is an abstract game. It is essentially this, but without any moving forward, without a net. All it is preventing a ball from going past each person, right? So that is an example of an abstract game. Another abstract game, you have soccer, you turn it into foosball. Okay, that is an abstraction of soccer, where they don't have the same things. You, depending on your choices, you could make foosball different. I know I've seen like human-sized foosball before, where you actually have people that have to hold on to metal rods. But that's what an abstraction is. It's keeping some things and getting rid of a whole bunch of other stuff. Is it the same? No, but is it a good proxy? Yeah, it's still fun. So the goal is to take any game down, tear it down to its core, and then build the game that you want. So the students get to pick whichever game that they want to do. It could be a different video game, could be a sport, it could be like something very, very simple. It doesn't have to be yeah, it can be any kind of game. It doesn't have to be a sport, just could be anything. If you want, you could provide a list of sports for them to pick from. If you think that, oh, anything is too broad, you can provide a list of sports that would work really well. But yeah, they're going to self-differentiate based on what they pick. They might pick something easy, like Pong. Pong you could build pretty straightforwardly. They might pick something more difficult, like foosball, or like a digital version of foosball. And then they're abstracting foosball, so it's another level. But either way, depending on what they're interested in, they're going to pick something that matches their level most of the time. So it's really nice that way. Okay, so this is the one that I made. I'm a huge golfer, so I decided, oh, I'll just do this as a quick example. So I made a golf abstract game, and this is all it is. It took 15 minutes. I could have spent way more time on this, honestly. I was getting off track. I was like wanting it to do all these things. I was like, no, I have to calm down. This is just for a presentation. I don't actually have to show anyone else. But once you get into coding and you want things to happen, it gets really addictive, actually. So here's my golf game. I'll just expand it. Here's my abstract golf game, right? It's just a ball in a hole. And all I do is when I press up, let's see, green. There we go. press up, it goes up closer to the hole, and you'll notice it's always a little to the right, just like my real life golf shot. Okay, and then I have to go back and forth, and once the ball gets in the hole, the game's done. Great. Okay, so like that's a very simple abstract game that doesn't take super long to build. Now the students will probably want to build bigger or build more, like spend more time on it, or maybe this is a little too complicated for them. So you can scale it back and help them with some of the math. For example, this is grade 5, this is grade 6, but you can see here there's integers starting, -30 and -100, and adding, so there are other curricular elements. It's not just purely computer science, but in grade 6, that is an entire element anyway. So you have to teach it regardless. So this is just an idea of something fun that the students could do. They'd be invested in it because all you're doing is making a video game, right? But you're making a video game that's like a real game, so you have a kind of a map to go on to, and then they're abstracting. So I think that could be pretty positive as a thing for them to do. So here are the outcomes that you'd be hitting with doing that project. You have abstraction, you have generalizing patterns, which is huge in computational thinking, removing unnecessary details, abstraction, again, creating a computational artifact, making an app. Like this is essentially what they're doing, is making a video game app. It's very, very similar. So they have to use sequences, if else statements. So if this, then that, they have to be able to do that. So if the ball goes in the hole, then the game is over. Okay, so that counts as an if this then, or sorry, if then else statement. Loops again, talks about sequences, order sets of instructions within a code. That was definitely there. Yeah, and conditional structures. So yeah, if then. So any questions about the grade 6 project? So again, as long as the students have a basic knowledge in coding and using block coding, I think they'll find it fairly intuitive in order to do this stuff. Okay, grade 6. So here's the grade 8 project. So because grade 8 doesn't have a computational science or a computational thinking part of the curriculum yet, in order to use it, you have to coordinate it with a different subject. So collaboration with humanities in this case. So the goal is to tell a story. With grade 8, I just picked one part of grade 8. So they have to study in grade 8 social, Aztecs, and the Spanish, and how like a bunch of stuff about them meeting together. So if they could create a story-based game based on those ideas, you'd be able to hit a lot of computational thinking ideas, as well as the actual curriculum from social. Okay, and then they're also doing something that would be fun to do. Well, yeah, fun to do while teaching kind of both things, which is nice. So again, you have the self-differentiation. You have collaboration, probably not going to have one person per story. Usually in social and English, at least my experience, there were a few times where you got to collaborate, but not usually on a story. But in real life, when people are writing stories, or like especially for movies and TV shows and things, they have to collaborate on writing the story. It's not usually one person. Sometimes it is, but collaborating on a story could be an interesting thing for them to do that they might not have done before. And also creating within a box can be helpful for some students. So I know we always talk about creating outside the box, but sometimes creating inside of a box and seeing what you can do with restrictions can end up being a little bit more creative than you might have otherwise been. When the whole world is open sandbox, that leaves, paralysis from choice. You can do anything, so pick anything you want. Well, that's really, really difficult for anyone to do, never mind just students. And so if you give them a box, and it allows them to create within a box and be creative inside of the box. Right? Think of all the a lot of good movies are on purpose, put themselves in boxes, and then kind of flips the expectations, right? So that's kind of what the idea is. So there is a history of story-based games already. I did not make a story-based game for you guys, but I did have a couple of ideas that already exist. So the first one is called Never Alone, which is an adventure platformer. So similar to think Super Mario Brothers, but it's telling a traditional story from the Inupiat peoples in Alaska, where they incorporated elders and storytellers and community members, and the video game creators kind of meshed it all together to make a really beautiful game. I think it's about 10 years old now, but maybe a little older, but it's a really, really cool game. We can just watch, I'll just show you a clip of the trailer here. So this is like some in-game play right here. You can see that it's very artsy, it's telling a story, but at the same time, if you were to break it down, if you were to abstract it, it's essentially similar to Super Mario. There's not that much difference in terms of the mechanics of the game, not the actual presentation. It's way nicer to look at, in my opinion. So that's an example of a game. So you could have that where the students make a platform game and then they tell the story in between or as you go. But there's a lot simpler games as well. So here's one called When Rivers Were Trails, which is another Indigenous game. It's similar to Oregon Trail, but it's fully free. You can just go to this website that I have. All the things are linked in here, and you'll get a copy of the presentation after anyway. But basically, you just download the game and you're good to go. You can play the game for free. And it's similar to Oregon Trail. You have to make decisions. You're heading west because of some trees that were broken. And it's a pretty cool game. It's a clicker. It's not super complex. It's not like this one that's 3D. It's more so straightforward, but still, I've seen people make, colleagues make those kinds of games where you have to click on a specific object and it takes you to a bunch of dialogue and you have to figure out what to do next, and you make one of two choices and then it branches off and branches off and branches off. So you could definitely do that with the Aztec Spanish ideas.
So I have a question.
Yeah.
So as a language arts person, that really intrigues me. Is that the kind of game that students could create using Scratch, or would that be, because I know you can do just general choose your own adventure with Google Slides, but with Scratch, you have that animation piece and the coding.
I would say I'd say an average student would be able to do the Oregon Trail clicking type game.
Yeah.
That's not super difficult.
And that's just in Scratch.
Just in Scratch, for sure in Scratch. Yeah. The hardest part is definitely the logarithmic choices that start to pop up.
Right.
If you have 2 choices or 3 choices at every turn,
you have to storyboard it all.
20 different games.
Right.
So then you might have to rely on some old tricks that video games still do, right? Where it seems like you have a choice, but really the only thing that changes is the dialogue, and then you end up doing the same thing anyway. So I know a lot of gamers have issue with the new Harry Potter game because it seems like no matter what choices you make in the game, you still end up with the same storyline,
Ah,
which is, that was a $1 million game to produce, and they're still using those tricks. So that would be something you could discuss, or maybe you only have. I know a very famous game from 20 years ago was BioShock, and BioShock was so unique because it mattered what you did in the game, and depending on how well you played, how good you were morally while playing the game, you'd get one of 3 different endings, right? So even that is still better than having 20 stories, but it still feels like there's a difference. So that, yeah, you could definitely do something similar in Scratch. The platformers I've seen made in Scratch, they're okay, they're a little clunkier. But if you have someone that is really interested in this stuff, they could definitely make something like that. Obviously, it wouldn't be 3 dimensions, it would be more 2D,
yeah.
a 2D platformer, but yeah, you could definitely still do it. I had a group of grade 9 students make one when we were doing the electricity unit, when I was doing the big project for that, which is my next presentation. That's what that one's about. So I had some students make something for there. Oh,
Okay, good, thanks.
yeah, no problem. So these are the grade 8 outcomes. Again, they're mostly social-based outcomes. I could have picked something for English, I'm sure, that, or this could be like a social English collaboration because it involves stories, it involves culture, it involves all the things that, actually, this last one was really interesting. I'm a science, sometimes I'll teach phys ed, but I don't usually look at the social curriculum. But when I was looking, it was actually in there, create a simulation or a model by using technology that permits the making of inferences. So that sounds pretty close to what this would be. Like closer than what I thought it was gonna be anyway. So yeah, that's the idea for the grade 8 project. Any questions about that?
I had a question. How much time would you expect this to take?
Yeah, so for these ones, like it could be very, very simple. Like I would say it depends on how often the class is, but probably a couple weeks, like this story-based games depends on how long you would do it normally, but I'd say probably a couple weeks would be okay to at least get the general gist down. If you wanted to expand this and make it a huge project, you could definitely do that. But my initial idea with all of these is like roughly 2 weeks. Any others? Okay. Okay, so the last one is the grade 9 project. So this would be designing an organism, which I thought would be a kind of a cool idea. So the general idea is you design an organism inside of a relationship. So a relationship like predator, prey, parasite, host, that kind of thing. Or like in a commensalistic relationship. So you design an organism that is inside of a relationship. Then students pick why it would be successful in its ecosystem. So what about it is special? Why is it able to live in its environment? And then they show their organism being successful using code. Okay, so that seems like pretty straightforward, definitely a shorter kind of project. So it could show the organism hiding or being totally blended in, or whatever. Maybe it's just really large and it's showing it chasing other things, like whatever it wants, whatever the students want to pick, that's the thing that would make their object special or their organism special. It doesn't even have to be an animal, could be a plant, could be a fungus, could be bacteria, whatever they want to do. And that's the idea. I didn't make one for you, but what I did, I found this game on Scratch just to show you the kind of the possibilities that could exist. So this game is kind of funny. It's how to design your own bunny. So all it is, I wish I could shut off the shut off the sound, but I think it's just going to be stuck with us. But basically, all you do is you get to pick what the bunny looks like. So these are things that you can do in Scratch that are pretty basic, where you have an organism, you can have it change a couple things, and then that's it. And then that, like, the whole point is more so the organism rather than the coding. So you don't want to spend, there we go. You don't want to spend too long on this stuff. But if they have a basic understanding of coding, this is one way that they can present it without needing to be able to draw. They can do it with a group, so they're collaborating. They're, you know, using computational thinking skills to do something in biology, which might be a little different. So I know I'm coming from an art school, so this is something that they would probably enjoy. I know one of my partners has like a design a dragon thing that he does. Here, I'll pull it down actually. So they have a design a dragon. Looks like that. Oh, it's all blurry. Come on. Oh, that's great. Okay, unblur me. Let's see. There we go. So this is like the dragon that the student drew, and then it has explanations over what the things are on the dragon. Okay, I think this was this might have been Bio 20, but this is the same thing that can apply, right? So they're designing an animal or an organism, and they're seeing what that animal can do. Yeah, and it doesn't have to be a crazy game. It can just be like a press play, it does it, and then there's no actual controls. Like it doesn't need to have controls. It doesn't need to be super complex. The students could definitely do it within a couple classes. So that's the idea there. So the grade 9 outcomes, we have describing examples of variations among species. So what makes your fake organism different? What niche does it fit into? You can get them to answer a whole bunch of questions separately if you want. And then they get to show it off to other students, which that's always their favorite part, is the day where they get to play everyone else's video game or play everyone else's program. Yeah, so they get to talk about diversity, changing environmental conditions, so you can show how, while this camouflage works well in its ecosystem, it would not work well in an Arctic ecosystem because the organism is green, not white, for example. Yeah, you get to classify symbiotic relationships. So how is your organism good inside of its relationship? What does it do to the other organisms? And then how does your species help the survival of another species? Or if it's a parasite, how does it hurt the survival of another species without killing it? So those are the outcomes from grade 9. Okay, those are the projects. I'm a little early for time. Usually I try to extend it by 10 minutes, but I'll make a note of that. But my next session is on more complex coding projects on February 5th. So that's in a couple weeks. But yeah, that's it. If anyone has any questions or want to discuss anything with me, I'd be happy to help.
I have a question.
Yeah.
So I was thinking, like in terms of your background, like you've obviously, you know, come to coding like through a science kind of a background.
Mhm.
And of course, like I remember hearing how initially when they were working on the computer science curriculum, it was associated with math. And then as things got revised, it was then integrated into science.
Mm.
And so as a science teacher, what do you think about that fit? Because I think all of us in the room can see that it obviously can fit everywhere. But how do you see science like as a choice? Like if someone was teaching in elementary or junior high to say, actually, yeah, science is where I'm going to put this. Like, what's your thoughts about that?
Yeah, that's a great question. When I did the project, like the bigger project I was talking about with electricity, I combined it with the math class. So it was a math science combination thing. I can see, yeah, I can kind of see how it fits with math, but when you get down to it, a lot of what you're doing in coding has more to do with the way you're thinking rather than actually doing math. Like most coding projects that I've built have involved like a small amount of math, but most of it is how to use it correctly, which kind of fits more into like ways of thinking like a scientist rather than a mathematician.
Is it
But
because
that's a really tough question. I'm not sure exactly, like, I can see both sides, like why it would fit in each one.
do you think it might have to do with the content? Because in school in science, and I don't know, I'm not, but I tend to think of in school in science that it's sort of precise, like it's precise things that you're trying to learn and identify and grapple with. Whereas, you know, if you're telling stories, that's a little bit more sort of ambiguous, or
Hmm.
I don't know. And I'll just open the question up to, you know, anybody as well.
Yeah, no, that's a good question.
Uh,
I'm not sure if there's one right answer.
But I've found like through your examples that the fit with science seems really like it just slots together.
Yeah, I see what you're saying. It does depending on which unit you're doing, right? Like, and I'm sure with math, I think it might be just because science has a lot more visual things that you can do with it. Whereas
Yeah, that makes sense.
math, you can do visual stuff with it, but it just ends up being like, I taught junior high math for a bit, and there's not a whole lot there's not a whole lot of visual stuff. Like you can do math in the background of it, but to make the project math would be very difficult. Yeah. Might be
Yeah, that
because
makes
of the
sense.
amount of visuals.
Any other questions for Braden?
Well, thanks so much for coming. I would appreciate any feedback that you can give on the feedback form, just because I have to give this presentation again. So I want to make it better if I can. Yeah.
Sounds good. Well, look, thank you so much for your time. There are a number of people in here who are doing the 24 hours of sessions towards the tech in schools. And so it's nice that they can go away and think about it for 15 minutes and still be within the hour. So thank you everybody for coming and for your time this afternoon. And thanks, Braden, for sharing your ideas. Oh, you know, before we go, could you put the link to your presentation in the chat?
Yes, sure.
And then we'll just have it. And I'm
Yeah.
going to stop the recording.